Pandas are majestic eaters of bamboo and very good at sleeping for long periods of time. But they also have a secret power, chomping down on large datasets. Today, we'll introduce one of the most powerful and popular tools in data wrangling, and it's called Pandas. When you think of data science, Pandas is probably not the first thing that comes to mind. These black and white bears spend most of their time eating bamboo and sleeping, not doing data science. But today, we'll use Pandas to manipulate our datasets and set it up for machine learning. I can't do the entire library justice in just one video, but hopefully this overview will help you get going. And I'll leave it to you to explore the fascinating world of Pandas in more depth. Pandas is an open source Python library that provides easy to use, high performance data structures and data analysis tools. Cuddly bears aside, the name comes from the term panel data, a common term for multidimensional datasets encountered in both statistics and econometrics. To install Pandas, simply run pip install pandas inside your Python environment. Then we can import Pandas as PD. One of the most common things that Pandas ends up being used for is reading in CSV files using the read CSV function. It is often the starting point for using Pandas. Pandas loads this data into a data frame. This can be thought of as essentially a table or a spreadsheet. We can take a quick glimpse of our data by calling head on our data frame. Data frames have rows of data with named columns, which in Pandas are called series. For me, one of the nicest things about data frames is the describe function, which displays a table of statistics about your data frame. This is super useful for sanity checking your dataset, seeing if the distribution of your data looks reasonable, and whether the properties are what you expect them to be. I also sometimes will use Pandas to shuffle my data. This can be useful in situations where you want to shuffle the entire dataset rather than merely having a look-ahead buffer as you extract data out. For example, if your data is not shuffled at all and is in fact already sorted, you'd want to give it an extra good mixing. However, for truly huge datasets, it's possible that this may be impractical without more sophisticated approaches. To access a particular column of a dataset, use bracket notation to pull out that column, passing in the name of that column. If you're wondering what the possible column names are, you can look back at the output of .describe or use df or dataframe.columns to access all the columns in the dataframe as an array. If you can access data column by column, then the next thing you'll want to know is how to access it by row. Accessing rows of data frames is a little bit different than from columns. For example, if we want the row with an index I of a given data frame, we can use iloc or ilocation, index location at I. Keep in mind that Pandas operates on a zero-based indexing system, so the first row is actually indexed 0. Sometimes you may want a particular row and column. Because rows and columns are accessed differently, we'll need different techniques to get that done. In particular, if you want row 5 of a column called name, you would use something like this. And where things get much more interesting is when you want to get a whole range of columns and rows. On the column side, the way to get multiple columns is to pass in an array of those column names. If there are many columns and you don't want to type them all out, you can use the columns array, the .columns array, and select a range of column names from there, and use that to select columns. If we want to get a range of rows, we can use colon notation inside the brackets that follow iloc, like so. And the starting index here is included, while the ending index is excluded. So this will return row indices 5, 6, 7, 8, and 9, but not row index 10. Say we wanted both a subset of columns and a subset of rows. What would that look like? Well, we can combine what we've learned so far and make one expression that gets the job done. So first, we'll choose the column names just like we did before. Then we get the columns back, and then we can select the rows from that data frame using that colon notation. And so once you get the hang of things, you'll actually be able to collapse these 3 lines down into just one expression, something like this. And if this is the first time you're seeing this sort of collapsing, I'd encourage you to pause here and look at how this expression is exactly equivalent to what we showed earlier. I'll still be here when you get back, so Happy to wait. We've looked at some simple data manipulation in this video, and there's much more that the Pandas ecosystem offers, from efficient file storage in the form of Pi tables and the HDF5 format, to running certain statistical analyses. Now, this has been just a quick overview of what Pandas can do, so check out the documentation links below to start your journey with Pandas. Thanks for watching this episode of Cloud AI Adventures. Be sure to subscribe to the channel to check out future episodes right when they come out. For now, get out there and try pandas in the wild.